In this video, we will go over an example of how to handle the calculations for a weak acid, strong base titration. The first step in any of these problems is figuring out your stoichiometry. To do that, you can set up a fake rice table where you write out the reaction, you write out the initial moles of your reactants, and then you figure out who the limiting reactant is to find the change, and then you write down your ending moles. We'll then need to change those ending moles into molarity to use in a real rice table for the second half of the question. So for now, let's figure out what we're starting with. We have some acetic acid and some sodium hydroxide. Sodium hydroxide is a strong base, so I know that when I write out my acetic acid plus my sodium hydroxide, that my active part is just going to be the hydroxide ion. I also know that these two compounds are going to react to completion as much as they can to form acetate and water. Okay, now we need to calculate the moles of the acetic acid. We have 25 milliliters, so that's the same thing as 0.0250 liters, and I will multiply those liters by the 0.1 molarity. This leaves me with 0.0025 moles of acetic acid. Then I'll do the same calculation for the sodium hydroxide. Those 15 milliliters are the same thing as 0.0150 liters, and I'll multiply that by the molarity to get 0.0015 moles of the hydroxide. Now, I just need to look at my 1-to-1 mole ratio and realize that my hydroxide is a smaller number. Since this reaction goes to completion, I will subtract all of it. This leaves me with no hydroxide, an additional 0.0015 moles of acetate, which is going to be very important for the next part, and 0.001 moles of acetic acid left over. So now we need to convert these moles into molarities by dividing these moles by the total volume. We can see that our volumes are 25 milliliters and 15 milliliters. So we just need to add those two together. 25 plus 15 equals 40 milliliters. And in liters, that's going to be 0.04 liters. Don't worry about the sig figs until the end, which means that my acetic acid is going to have a molarity of 0.025, and the acetate will have a molarity of 0.0375. Again, I'm keeping my sig figs all the way until the end. Even though I'm supposed to have 3, I would just keep more for calculations. Now I need to put these molarities into a rice table. Before I can get a decent rice table going, I really need to consider what is in my beaker right now. I have significant concentrations of both my weak acid and the salt of my weak acid, or the conjugate base. In this case, I need to figure out if I'm using the reaction for the acid or the base. In all honesty, I think that the chemistry overlords would make you compare the Ka values of each species to figure out which one would win, but honestly it won't matter. As long as you use the Ka for the acid written reaction and the Kb for the base one, you should be okay. Since our question is asking for pH anyway, let's focus on the acid version of this problem. This means our new and improved equilibrium rice table should have acetic acid reacting with water to produce acetate and the hydronium ion, which we can use to calculate pH. So now I'll set up my rice table and we can insert those initial concentrations we just calculated. Acetic acid starting concentration 0.025 molarity and acetate starting concentration 0.0375. Since we're starting with a theoretical zero amount of acid in the beaker, because we had just added sodium hydroxide, which would have eaten all of those spare ones in solution, we can assume there's going to be a small change where there will be a little bit of product added to reach equilibrium. Okay, now is a good time to set up your equilibrium constant expression where the Ka is equal to the products over the reactants and use the 5% rule to get rid of those plus and minus x's. Our starting concentrations are over 100 times bigger than the K value for acetic acid, so we should be good to go. 1.8 times 10 to the negative 5, gotten from a table inside of your textbook, is equal to x times 0.0375 divided by 0.025. We do some algebra math to get that our x value is equal to 1.2 times 10 to the negative 5. And then we think to ourselves, well, what does my x value actually mean? And then I remember from my rice table that x is the H plus concentration, which means that all I need to do to answer the actual question is calculate the pH. Since pH is equal to the negative log of the H plus concentration, I will just negative log my answer to get a pH equal to 4.92. So just to reiterate, for all of these weak acid, strong base titration calculations, there's two main steps. You need to do some stoichiometry with limiting reactants to figure out what is left in your bucket. If you have some weak acid left over, set up your rice table with the weak acid as a reactant and the salt of that weak acid as the product. Then do a regular equilibrium rice table and calculate your pH.